Hi everyone. At the end of yesterday's lesson, I gave you a little preview of lesson 1-4. We're going to just touch the surface of equations and inequalities. We're not going to solve anything, we're just going to look at how they're represented. Up until this point, we've only talked about expressions. So in today's lesson, we're going to look at two types of mathematical sentences. First, the equation. It's a sentence that states that the two sides are equivalent. In the second type, which is the inequality, we're looking at another relationship and it uses these four symbols. The solutions to equations and inequalities can be graphed on a number line. If I solve an equation and I get x is equal to 3, I would graph or plot that solution by just a solid circle or dot at 3. That's the solution. That's the only number that would make that equation true. If I solved an inequality and my solution was all real numbers where x is less than -4, it doesn't include -4, so that will be the open circle and shading everything that is less than. So again, -4 is not part of the solution. The third inequality I have given here is x is greater than or equal to 5. Once I see this line underneath, it reminds me that it's equal to, so I close the circle once again, and it also includes all the numbers that are greater than into positive infinity. So we have a single solution for my equation most of the time, and we have inequalities which will have infinite solutions depending on the parameters. So closed sentence contains no variables, open sentence has at least one variable. We're going to be not solving in this, we're going to be checking. We're going to check solutions for inequalities as it states here, but also equations. I have then shown the representation once again of when it's an open or closed circle and when we have shading to the left and shading to the right. These two statements are open sentences because they both contain a variable. Again, I say we're not solving in this section, we're checking, and we're going to check to see if 5 is a possible solution. How will I do that? Substitute. You're going to substitute in 5 for the variable. So 3 times 5 minus 2 equals 13. I have 15 minus 2. And if the two sides are equivalent or equal, I can make the statement that 5 is a solution. Because it makes the statement true. Once again, I'm going to use 5 because that's the number I'm testing. This time I'm putting it into an inequality. I'm going to do the same process. I'm going to simplify and see if this now makes a true statement. 13. Is 13 less than 13? It is not. So I can say 5 is not a solution. And that's all we're going to do with these for the time being. We're going to substitute in values, and what we're doing actually is the check. So when we do actually solve equations and inequalities, and I say let's do the check, this is the process that you will be using. Test to see if the following is a possible solution. I did it with, once again, an equation and an inequality, and let's see how this works. And I switched it up just a little bit. I've got 2 times 3, we're substituting in. We're going to simplify using a little order of operations here. And I get 10, and 10 does not equal 12, so I would say 3 is not a solution. So basically, solution or not a solution? That is the question. Let's try it with this inequality. Let's put this 3 in here. Is 6 plus 4 greater than or equal to 10? Is 10 greater than or equal to 10? Well, if it didn't have the equal to symbol on there, it would be false, but this is a true statement. 3 is a solution. So once again, not solving, but sort of checking. Does this number work to make a true statement? Again, an open sentence is a mathematical equation or inequality that contains a variable. And all we're doing is testing out possible solutions. I have given you an equation and an inequality, and I've given you 3 numbers to test for each. Please copy these in your notes and test them out. We'll go over the results during our session. Now, I did say at the beginning of the lesson that we were going to use this term equivalent one more time. The final thing I'm asking you to do in this video is to find as many ways you can to name 12, something that's equivalent to 12. And we are definitely going to go over this list in our Zoom class today. So I want you to take a minute or two and find as many ways as you can to name or write equivalents to 12. Homework is going to be in our textbook. Now that everybody has one, we're going to go back to the previous section and do a little bit of work there. And then we're going to use some of these to do for today's lesson. So please make note that in one section we're doing the odds, in the other the evens. We'll meet up in class, and until then, have a good day.